tutorial. In this tutorial I will try to explain you what is compiler and how it works. So suppose a user want to execute a program in his computer. He writes a program in high level language, some things something like that. But if you give this a program written in high level language to CPU, then CPU would not execute it because CPU do not understand this high level language. So what we need another software that will translate this high level language into another form so that the computer understand it and execute it. So we need a type of software that is called compiler that converts this high level language into another form that is machine language. So the compiler is a type of software that take as an input one form of program and convert it or translate it into another form. In this case here, this compiler is taking as an input the high level language and converting it to machine code. So these machine codes can be executed in your machine and computer understand it. So this is the job of compiler, to translate or to convert your high level program into machine code. The compiler is very large and complex. In order to make it easier to understand compiler, we need to divide its working into small phases, and we can focus on understanding each phases one by one, and that's how we can it would be easier for us to understand the working of compiler completely. So suppose this is your compiler, and what we did, we have divided the working of compiler into small phases, and this is your phase 1, 2, 3, 4, 5, 6. So we have divided the working of compiler into 6 phases. The first phase is called your lexical analyzer. This is the first phase. That this takes as an input your source code, which is nothing but a sequence of characters. So this lexical analyzer has some information about the keywords, symbols, operators, information about the keywords, symbols, operators of the language. So based on these, lexical analyzer check the patterns on input and group together these sequence of characters, and these groups are called tokens. So basically the lexical analyzer tokenize the input. For example, if we if we give lexical analyzer uh, this this line as input, we give it as input, then it check the pattern on this sequence of character separated by a space. So it find that it doesn't match with the keyword, so it must be an identifier. So what lexical analyzer does that, um, it record this pattern into symbol table. Symbol table is a common data structure which are accessed by all phases of the compiler. So it record this is the index value and this is the name and its value, and its whatever other related information, you can record it, and here it can create a token and reference it with the symbol table. Next it check for another pattern. We find it is a assignment operator. Now let's check for next pattern, and the lexical analyzer, by checking the pattern, identify that this is not a keyword, so it must be an identifier. So it recorded another identifier here and its corresponding value. It record it and create another token. Now next operator, another identifier, record in a symbol table, and then create a token. Next operator and next integer value. So that is how it creates these tokens, and these tokens are sent to next phase, that is called syntax analyzer phase, and it also has a set of rules in the form of grammar. So it checks whether the given input is valid or not based on these grammars. So it's basically checking these syntax error. Now after that, it passes this information to next phase, that is semantic analyzer. Semantic analyzer performs the things which cannot be performed in the previous phase, like type checking, type conversion, expression evaluation, and many more other things are performed in semantic analyzer phase. Then information is passed to next phase, where next phase is called intermediate code generation, where the intermediate codes are generated. These codes are similar to the machine code but are not very specific to any target machine. So that's why these codes are called intermediate code. and then these intermediate code are passed to next phase where code optimization are performed. In code optimization, we eliminate unnecessary codes like duplicate codes and which are useless. These codes are eliminated, make it smaller, and these optimized code are then passed to the final phase, that is code generation phase, where these optimized codes are converted into target specific machine code. Something something like that. And these code now finally can be executed in your computer. So that is how our compiler works. We have divided its working into phases, and I gave you some little bit of information about each phases. I hope you understand this. Thank you very much for watching this video.